Ever wondered how Azure's architecture is built? It's a fascinating blend of innovation and technology, designed to offer a robust foundation for cloud services. This architecture is built on a set of core components, each playing a critical role in providing the flexibility and power that Azure is known for. Understanding these components isn't just a matter of curiosity. It's a crucial step in designing, deploying, and managing applications on the Azure cloud. From Azure regions, which are the geographic locations where Azure data centers are located, to Azure Resource Manager, the deployment and management service for Azure. Each component has its unique role and significance. Then there are Azure Compute, Azure Networking, and Azure Storage, each offering a range of services to ensure seamless operation of your applications. These are just the broad strokes, of course. The real magic is in the details. So, without further ado, let's dive into the key architectural components of Azure. First up, we have Azure regions. Think of these as the geographic locations across the globe where Azure's data centers are located. Now, each Azure region is paired with another region, a neat little trick for redundancy and disaster recovery. This pair is like a safety net, ensuring that if one region faces an outage, the other steps in to keep your services running smoothly. But Azure regions are not just about disaster recovery. They play a vital role in optimizing latency. By selecting a region closer to your users, you can significantly improve the response time of your applications. It's like choosing to shop at a neighborhood store instead of one across the town. The closer the store, the quicker you can get what you need. Now, let's talk about data residency requirements. In this era of stringent data protection laws, where your data resides matters. Azure regions help you comply with these requirements by allowing you to choose where your data is stored. So, if a regulation requires your data to stay within a specific country or region, Azure has got you covered. All these factors underline the importance of Azure regions. They ensure high availability of your services, aid in compliance with data residency requirements, and help optimize latency. Remember, the choice of the right Azure region can significantly impact your cloud strategy's effectiveness. Choosing the right region is a crucial step in optimizing your Azure usage. Next, we talk about resource groups. At their core, resource groups are logical containers that encapsulate related Azure resources. Think of them as your own digital toolbox, a place where you can neatly store and manage all your Azure tools. Each resource within the group is managed as a single unit, which simplifies the management process, making it more efficient and effective. But what really makes these resource groups shine is their role in resource deployment. They provide a way to deploy, update, and delete resources that share the same lifecycle in a single coordinated operation. This eliminates the hassle of individually managing each resource, saving you time and effort. Moreover, resource groups are a great way to organize your resources. You can group them according to lifecycle, ownership, or even by the region they're located in. Resource groups, therefore, streamline the organization and management of your resources. They're like the backstage crew, ensuring that the Azure performance runs smoothly and flawlessly. Moving on, we delve into the Azure Resource Manager. Imagine a conductor guiding an orchestra, ensuring each instrument plays its part at the right time. In the world of Azure, that conductor is the Azure Resource Manager, or ARM for short. This deployment and management service is the backbone of Azure's operations. It's the central hub that enables you to provision and manage Azure resources. And how does it do this? Through the use of declarative templates. Think of these templates as a blueprint for your cloud environment. They define what resources you need, their configurations, and how they interact. This blueprint can be used to create and manage resources consistently. For instance, if you're deploying an application that requires a database, web server, and storage account, you can define all these in an RM template. When the template is deployed, Azure Resource Manager will create these resources in the correct order, ensuring dependencies are handled appropriately. But ARM is not just about deployment. It's also about management. Once your resources are deployed, ARM provides a unified management layer. You can apply tags, manage access control, and even audit your resources, all from one place. So ARM is like the conductor of your Azure orchestra, ensuring every piece is in harmony. It takes the complexity out of deployment and management, allowing you to focus on what really matters: building and running your applications. Azure Resource Manager allows for consistent and repeatable deployments, simplifying your cloud management tasks. Now, let's focus on Azure Compute. Azure Compute is like the engine room of the Azure cloud, powering the applications and workloads that drive businesses forward. In this arena, you'll find virtual machines, Azure App Service, and Azure Functions, each playing a crucial role in providing scalable computing power and running applications. Virtual machines, or VMs for short, are the workhorses of Azure Compute. They provide scalable computing power in the form of virtualized servers. Whether you prefer Windows or Linux, VMs allow you to run your applications seamlessly. Think of them as your personal, customizable computers in the cloud, ready to handle the heavy lifting. Next up is the Azure App Service, a fully managed platform for building, deploying, and scaling web apps. It's like having a dedicated team of experts to manage your app's infrastructure, so you can focus on what you do best, creating amazing apps. With Azure App Service, you can develop in your favorite language, be it .NET, Netcore, Java, Ruby, Node.js, PHP, or Python. It's all about giving you the freedom to create without constraints. Last, but certainly not least, we have Azure Functions. This is a serverless compute service that enables you to run event-driven functions without having to manage any infrastructure. It's like having an invisible helper that springs into action whenever a specific event occurs. Azure Functions can scale on demand, and you only pay for the compute time you consume. This makes it an incredibly efficient and cost-effective solution, especially for microservices architectures and real-time data stream processing. Together, these elements of Azure Compute form a powerful trio, each with their own strengths, but all working towards a common goal: to provide you with scalable, flexible, and efficient computing power in the cloud. Azure Compute offers diverse options to cater to your specific application needs. Next on the list is Azure Networking. This key architectural component of Azure encompasses a variety of services, each designed to ensure secure and efficient network environments within the cloud. Let's dive into the first component, the virtual network, often referred to as VNet. VNet is your private playground in Azure. It provides an isolated and secure environment to run your virtual machines and applications. Think of it as your own private network within the Azure ecosystem, where you have complete control over IP address ranges, subnet creation, routing tables, and network gateways. Next, we have the Azure Load Balancer. As the name suggests, this component is all about balance. It's a traffic cop of sorts, distributing incoming network traffic across multiple servers. This ensures no single server is overwhelmed with requests, providing high availability and resilience. It's like a busy intersection in a city where traffic is efficiently managed to prevent congestion. Moving on, we have the Azure VPN Gateway. This vital component provides secure and scalable connectivity between your on-premises networks and Azure. It's like a secure bridge, allowing data to travel safely between your local network and the Azure cloud. It's particularly important for organizations that require a hybrid cloud setup, blending on-premises resources with cloud-based infrastructure. Lastly, we have the Azure Application Gateway, a specialized load balancer focused on web traffic. It optimizes and secures application delivery by routing traffic based on URL patterns, offloading SSL processing from your servers, and protecting your applications from common web-based attacks. Think of it as a VIP concierge for your web applications, ensuring only the right kind of traffic gets through and that it is directed to the right place. In essence, Azure Networking is a suite of tools that work together to provide a robust and secure network infrastructure within the Azure cloud. From VNets providing private network spaces, load balancers ensuring even traffic distribution, VPN gateways offering secure connectivity to application gateways optimizing web traffic. Azure networking ensures your applications run smoothly with optimal network configurations. Lastly, we have Azure Storage. This component is the backbone of data management in Azure, offering a variety of storage solutions to meet a wide range of needs. First up is Blob Storage, a scalable object storage solution perfect for handling large amounts of unstructured data. This could be anything from text files and images to video content. Then we have Table Storage, a NoSQL data store designed for semi-structured data. It's an excellent choice for storing flexible data sets, like user data for web applications. Queue Storage comes next. It's a messaging service that facilitates communication between application components, ensuring smooth data transfer and synchronization. Finally, we have Azure Files. This is a fully managed file share in the cloud that can be accessed via the server message block protocol. It's like having your personal secure file cabinet in the cloud. In summary, Azure Storage offers comprehensive solutions for all your data storage needs. In conclusion, Azure's architecture is built on key components that provide the foundation for robust cloud services. We've explored Azure Regions, Resource Groups, the Azure Resource Manager, Azure Compute, Azure Networking, and Azure Storage. Each of these components plays a vital role in optimizing latency, ensuring high availability, simplifying resource management, and providing scalable computing power and storage. Remember, understanding Azure's architecture and its core components is the first step towards efficient and effective cloud management.